Have you ever wondered what alcohol does to your body and why taking more alcohol can cure a hangover? No, not really. Anyway, let's talk about it. For us to understand this, we need to start by understanding this pesky little process that keeps everything in our bodies intact, and that is homeostasis. So simply put, homeostasis is a bunch of compensatory and regulatory mechanisms that keep the body at a particular rate. Put it in short, it's a bunch of processes that make your body be at a particular temperature, a particular pH, or just anything so that it can function properly. Let me break it down in such an easier manner. Imagine you're late for something like, I don't know, your wedding, and you start running. Now, because you're running, it means more muscle groups are working and they'll need to be sustained to get you from point A, which is your place, to point B, which is your wedding venue. This means more energy is needed to sustain all the muscle groups that are working together. And for this to be properly balanced, a steady rate of oxygen is needed. Actual science fact. Oxygen isn't necessarily needed in the production of energy in the body. However, it's used as a final electron acceptor that will be used in the production of water as a byproduct. Okay, back to the video. Now, your muscles need more oxygen and your body recognizes this and sends signals to your heart, making it pump faster and with more force. And remember from grade 6 science, blood is moved from all parts of the body to the heart, where it's pumped to the lungs for gaseous exchange, back to the heart, and then to all parts of the body. But now we have an issue. Remember, at this point, the heart is pumping faster and with more force. So it means the amount of time it's spending in the lungs has been greatly reduced. So from our grade 6 science, the lungs is where gaseous exchange takes place. Oxygen from the external environment enters into the blood, and carbon dioxide from the blood enters into the lungs, then to the external environment through a simple process known as diffusion, as we learned in grade 8. However, there is a rate at which all this takes place because carbon dioxide and oxygen are simple molecules with a certain amount of kinetic energy. Or simply put, there's a particular rate at which diffusion takes place. But now, because of the drastic change in the speed at which blood is passing through the lungs, these tiny little oxygen molecules be like, wait, let me just jump over this barrier. But then the red blood cells be like, hey, we're in a hurry, we're in a state of emergency. The glutes and other muscles need oxygen ASAP, ASAP, PCSAP, ASAP, ASAP, ASAP. Yeah. Okay, whilst that madness is happening over there, I just thought of this. Imagine it is date night and you want to watch, let's say, The Flash. It's starting at 10. Your wife be delaying and you really want to see how this movie begins from the start to the finish. So you're like, okay, I can't spend any more time here at home. I'm out. Peace. You find me at the movies. In this case, you as a husband are the RBCs, whilst oxygen is the woman who wants to take her time, who's used at working at a particular rate, or the oxygen in this case. Okay, back at it. This leaves the tiny oxygen molecules left behind and blood moving with a reduced oxygen presence bound to its hemoglobin. Hemoglobin is just a big science word for that weird molecule thingy that carries oxygen inside your red blood cells. Now, remember homeostasis? The body doesn't really like this. So here's the thing, because a reduced amount of oxygen inside cells, in this case, let's say your muscle cells, they will begin to produce lactic acid, which, if in excess together with other reactive species due to this imbalance of oxygen internally, this can disrupt cellular integrity. And also remember that other cells are also producing carbon dioxide at this point. Now, the increased amount of carbon dioxide in the bloodstream will then lead to the production of carbonic acid. And like the name states, it is an acid. Now, again, remember homeostasis. The body wants its pH to be at a certain level. It will be like, yo, something is up here. We need another compensatory mechanism, homeostasis, to balance up this change in pH. See? Science. So, what does the body do? It uses another compensatory mechanism. Of course, very simple. But wait, before we can even get there, let's understand this. Once this imbalance isn't properly controlled or homeostasis isn't kicking in fast enough, the body plays its last protective measurement. It will be like, hey, cells in the brain and in the heart aren't like those found in the liver and the skin that can heal themselves at super rates. So let's protect these two organs that are vital. Your body be like, this is a state of emergency. Engage a shutdown. And boom, just like that, your body stops and you end up fainting to protect these delicate organs, to reduce the amount of oxygen that will be needed or used by other organs. Science. So, the mechanism to counteract all of this is simple. Breathe faster. So simple. Oxygen molecules have a constant amount of kinetic energy. And remember, oxygen moves from the little areolar sacs in the lungs into the red blood cells through a process known as diffusion. Again, grade 8 science. Now, because this is diffusion, it means that the normal laws of diffusion will apply. In this case, two laws will be of great importance. The first one being concentration gradient. Now, at this point, your red blood cells are rich in carbon dioxide but low in oxygen, whilst the air sacs are high in oxygen but low in carbon dioxide. Because of this concentration gradient, the rate of diffusion will be made faster. It will be encouraged at a higher rate. So you have carbon dioxide leaving the red blood cells into the lungs and oxygen leaving the lungs into the red blood cells. And secondly, increased pressure. Remember, you're also breathing in faster at this rate. This increases the amount of pressure inside the lungs. And remember, the higher the amount of kinetic energy, the more molecules are vibrating, the easier it will be for them to diffuse across different membranes. So you have red blood cells that are working and moving really fast, and you have oxygen molecules that are willing to enter into the red blood cells faster. This means that you get to watch the flash in time, ironically, and it also means that there will be a reduction in lactic acid that will be produced inside the cells and carbonic acid inside the bloodstream, thereby regulating the environment that the body finds suitable for it to work, aka also known as one homeostasis. Boom! Science. Okay, whilst that guy is on fire, let me put it in simpler terms. Your heart is working faster, blood is moving all over the body faster, oxygen is needed at an increased concentration. So you're breathing in faster to counteract this so that there's a balance. Because you're working faster, your blood is moving faster, you also need to breathe faster to maintain this at a regular rate. Without this, there'll be an increase in carbon dioxide in the blood, plus reduced amounts of oxygen. It will lead to your blood being more acidic. Anyways, it lowers the pH in the blood, making it more acidic. Oof, the fire is gone now. So, we have covered that, but one thing still stands. According to the laws of thermodynamics, an increase in the production of energy means to more heat generation. The more your muscles are working, the more energy they are producing, the more heat is generated. This is why on a cold day, when you begin to walk really fast or jump around or do any form of movement, it kind of makes you feel a little bit warmer because your body is generating heat. Science. But remember this cool process known as homeostasis. Your body doesn't really want to be too hot unless you're this guy. And so the body wants a temperature that will be optimum for its different internal processes happening. And to quote Goldilocks, not too hot, not too cold, just perfect. So to solve this, the vessels near your skin will expand or dilate. And remember diffusion, heat will move from a region of higher concentration or where it's hotter, in this case, to a region of lower concentration or where it is cooler, in this case being the external environment. Science. So this leads to sweating, which is really just a way your body is trying to cool itself. In this case, heat is being lost from your body to the external environment. The same thing happens with inside your lungs. Heat from the vessels will enter the air sacs and is expired outside. This is why when you're doing certain strenuous exercises, you notice that your breath tends to be warmer than usual. Okay, now that we have a basic understanding of homeostasis, let's talk about alcohol in our next video. Why? Because science has shown that with the normalization of things like TikTok, Instagram Reels, stories or days, YouTube Shorts, WhatsApp statuses, no one really has got time to listen to some dude talk about science on the internet for a long period of time. Alright, thank you for watching this video. Part 2 will be on alcohol. Peace, love, and hugs. I'm out.